Hello, welcome back. So now it's time to look into the technical details of how to represent these semantic information, these vocabularies. And this is where we come to the next piece of this layer cake, the RDFS standard. So last time we talked about RDF for representing our data. And now we are talking about one more layer that helps us to describe the data. So to explain what exactly it is. If you think about the bookstore, here we have information like the author, but we want to have a description of what it actually means to be an author. So this is what we can do with this additional layer on top here. So RDFS stands for RDF Schema. It came out at the same time as the RDF standard, late 1990s for the first version. And the one that we are using, 1.1, came out in 2014. Originally, in the first standard, it was called the RDF Vocabulary Description Language 1.0 RDF Schema. But nobody ever called it that. Everybody just called it RDF Schema. So with version 1.1, they just gave up on this long name. And since then, the official standard name is also RDF Schema. So what this gives us is a way to describe our resources, to make statements about resources. A resource is a URI, or more precisely an IRI. So information like a university, a person, a book, but now we can add information what this actually is. It is a student, a person, an author, and so on. So this gives us the semantics, the meaning. Now semantics is meaning, and in this case, the meaning of these resources, of these URIs. Depending on where you come from, AI has a long history. There are lots of different technologies, like I showed you in the history slide last time. So for the same thing that we are doing, you'll find it described in different names. Sometimes people talk about schemas, sometimes vocabularies, sometimes ontologies. There are some small differences, but at this point, don't get confused. It means roughly the same thing in the context of what we are doing now. So the first description that we can do with RDF schema is describing a class of concepts. So this is something you should be familiar with from object-oriented programming. We have classes and instances. So we could have a class student, and then we have instances, lots of individual student objects, Joe, Jane, and so on. And these are instances of the student class. And then likewise, you can have a professor class and then different people like me as an instance of the professor class. One thing that's important and that's different from most object-oriented programming languages is that an instance can be a member of more than one class. If you're used to programming in Java and similar languages, that's not possible. If you program in C++, that's not terribly surprising. So here, let's look at this instance. What is this? Well, it's a Pokemon, but which one is it exactly? So we see a Bulbasaur, and this is a kind of monster that is both of type poison and of type grass. So this instance here belongs to these two classes. It's an instance of both classes at the same time. If you want to see more details and more Pokemons, have a look at this fun webpage here. So now we have to define that a certain URI is a class as opposed to an instance. And how do we do this? Well, we want to explain that the subject in the triple is a class. And the way we do it is we just add another triple. So we describe triples using even more triples. If you think about this the first time, it is a bit confusing, but I'll promise you, you'll get used to it. So let's look at the technical side. We want to define a new class, and we want to say this in RDF. So the way to define it is using just another triple. The subject is the name of the class. Then the property is RDF type. And the actual type it is that it's a class, RDFS class. And RDFS itself is defined under this URI here. So let's look at an example. We had the book store with various books, and one of the books we looked at was of type novel. So now we want to define a class for all novels. So we have the URI for a novel, and now we say that this is a class. This is of type class. If you're using Turtle as serialization, there is a nice shorthand. Instead of writing RDF type, you can simply writing A. So you can say novel A class. But this only works in Turtle. Don't write A if you're using another serialization format. There is a small exercise, but instead of stopping here, we'll just do the next slide as well, because both of them are short exercises, and otherwise we'll have too many videos. If you like, you can just pause me here and do the exercise, but I will stop the video after the next slide. So we talked about classes, but now we want to have instances as well. So we want to define that another URI is an instance of a certain class. So that Joe is an instance of student, or I am an instance of professor, or a certain book is an instance of type novel. So the way you do this is say that your resource, your I here, is of type C, where C is the class that you just defined previously. And again, in Turtle, you can abbreviate RDF type with simply writing A. So for example, we had the book here, URI for a certain book, and this is of type novel. So again, this is just another triple. So now you might already see that a very cool feature of this type of knowledge representation, namely that both the schema, the vocabulary, the meta information, and the actual data is in the same format. So if you want to add more information about what the data means, you're just adding more triples. If you think about other information systems like databases, they are separate. You have the schema on the one hand, and then the data in the database on another hand. And here, both are in the exact same format. So if I want to add more information, for example, you're reading information from one knowledge graph and you don't know about books and novels and authors, then you can just read additional triples that explain the data. And it all goes into one big knowledge graph. So now, if you haven't done so already, it's time for the worksheet again. So the first one, task 2, is about defining a new class. And then in task 3, you define an instance of the class and draw both information also in form of a graph. So have fun with that. And then I'll see you again in the next lecture part. Bye-bye.